Hello friends. Today's topic is 3D printing. To know about 3D printing we must understand about manufacturing technology. The manufacturing process refers to the steps or operations transforming raw materials or components into finished products. It encompasses all the activities, techniques, and procedures required to produce goods on a large scale. Manufacturing processes widely depend on the industry, product type, and desired outcomes. There are several types of manufacturing processes used in various industries to produce goods and products. Here are some common types of manufacturing processes. 1. Casting. 2. Forming. 3. Subtractive
Casting
manufacturing
involves pouring molten
4.
material,
such as
molding,
metal or plastic,
5.
into a mold
Powder
and allowing it
metallurgy,
to solidify.
6.
The mold
Extrusion,
is then removed.
7.
Leaving behind the desired
Welding,
shape.
8.
Additive
Forming
processes reshape and deform materials without removing any material. Examples include bending, stamping, forging, and extrusion. Forming is used to create components with specific shapes and properties, such as sheet metal parts, fasteners, and structural components. Machining is a subtractive manufacturing process where the material is removed from a workpiece using cutting tools to achieve the desired shape and dimensions. Processes like milling, turning, drilling, and grinding fall under machining. It is widely used in industries like aerospace, automotive, and precision engineering. Molding is the process of manufacturing by shaping liquid or pliable raw material using a rigid frame called a mold or matrix. This itself may have been made using a pattern or model of the final object. Powder metallurgy is a term covering a wide range of ways in which materials or components are made from metal powders. PM processes can reduce or eliminate the need for subtractive processes in manufacturing, lowering material losses and reducing the cost of the final product. Extrusion is a process used to create objects of a fixed cross-sectional profile by pushing material through a die of the desired cross-section. Welding is a fabrication process that joins materials, usually metals or thermoplastics, by using high heat to melt the parts together and allowing them to cool, causing fusion. Additive manufacturing is the construction of a three-dimensional object from a CAD model or a digital 3D model. It can be done in a variety of processes in which material is deposited, joined, or solidified under computer control, with material being added together, typical layer by layer. Additive manufacturing, also known as 3D printing, builds objects layer by layer using digital models or designs. It involves depositing or solidifying material, such as plastic, metal, or resin, to create three-dimensional objects. 3D printing is used in various industries, including prototyping, automotive, aerospace, and healthcare. Here's an overview of how a typical 3D printer works. 1. Designing a 3D model. 2. Slicing. 3. Material selection. 4. Printing process. 5. The first step is to create or obtain a digital 3D model of the object you want to print. This can be done using computer-aided design, CAD, software or using 3D scanners to capture existing objects. Once you have the 3D model, it needs to be sliced into thin layers using slicing software. Slicing software analyzes the model and generates instructions for the 3D printer, specifying the layer thickness, print speed, and other parameters. 3D printers use various materials, including plastics, metals, ceramics, and composites, depending on the type of printer and the desired object. Common materials for consumer-level 3D printers include polylactic acid, PLA, and acrylonitrile butadiene styrene, ABS, plastic filaments. The 3D printer begins the printing process based on the sliced instructions. It starts by heating the material to its melting point or activating the curing process. The printer then moves its print head or platform to deposit the material layer by layer, following the instructions from the slicing software. The layers gradually build up, adhering to each other to create the final object. Once the printing is complete, the object may require post-processing depending on the material and desired finish. This can include removing support structures, cleaning or sanding the object's surface, and applying any necessary treatments or finishes. There are several types of 3D printers, each using different technologies and materials to create three-dimensional objects. Here are some of the most common types. 1. Fused deposition modeling, FDM. 2. Stereolithography, SLA. 3. FDM is the most widely used 3D printing technology. 4. It works digital by melting and extruding a thermoplastic DLP filament, which is then deposited layer by layer to build the object. FDM printers are known for their affordability and ease of use, making them popular for hobbyists and desktop applications. SLA uses a liquid resin that is cured layer by layer using a light source, typically a laser or UV light. The light selectively solidifies the resin, creating the desired object. SLA printers offer high resolution and can produce detailed and intricate models, making them suitable for applications like jewelry, dentistry, and prototyping. SLS printers use a powdered material, typically a thermoplastic or metal, and a laser to selectively fuse the powder together layer by layer. The unused powder supports the structure during printing and can be reused for subsequent prints. SLS is known for its ability to produce functional and complex parts with good strength and durability. DLP printers are similar to SLA printers but use a digital light projector to project an entire layer of the object at once, solidifying the resin. DLP printers offer faster print speeds compared to SLA and can produce objects with high accuracy and smooth surface finishes. Binder jetting involves selectively depositing a liquid binder onto layers of powder material, bonding the particles together to create the object. Binder jetting is capable of printing in various materials, including metals, ceramics, and sand, making it suitable for both prototyping and manufacturing applications. Several metal 3D printing technologies exist, including direct metal laser sintering, DMLS, and electron beam melting, EB. Each technology has its strengths, limitations, and specific applications, catering to a wide range of industries and user needs. These are just a few examples of the various types of 3D printers available today. Hope you have understood the basics of 3D printing. Follow for more advanced science and technology related videos. Thank you.